Hello and welcome to another video from PiPad Mathematics. I am Professor Lamb, and this video we're going to be using the BrainingCamp Pattern Blocks app, and I've already established the settings that I prefer on this app, which is going to be a blank grid and opaque shapes. But of course you can change it depending on what it is that you're trying to work with respect to students and what you're trying to teach. But this video is going to talk a little bit about kind of creating two-dimensional figures that have symmetry and the concept behind symmetry. I will use some of the apps, or not the apps, the shapes that they already have, to where we take our green triangle and we're trying to determine if I were to draw a line, if I were to be able to establish a line that passes through my shape, would that shape be a reflection about that line? Would it have reflective properties, meaning we have what's on the left side of that line equals what's on the right side of that line? And for our triangle, we do have a line of symmetry here, to where we have what's on the left is equal to what is on the right. And we can also draw a line of symmetry that passes through this other vertex and passes the opposite side, and passes through this vertex and passes to the other side. Now, when you're working with young children, you're wanting them to be able to like draw lines, maybe put a mirror on there, a MIRA, which is kind of a somewhat transparent piece of plastic that allows it to reflect one side, but you can still see through to the other side and see where it would reflect on the other surface. And they want to explore and find these lines. And of course, because this is the equilateral triangle, we are doing things like the perpendicular bisector of that vertex, and so these are greater, I guess, vocabulary or greater elements that you can work with your older students. But here's a triangle, and here are lines of symmetry that we can work with on using these pattern blocks. Now we have our triangle there, and then we have our parallelogram, and with our parallelogram we're talking about a line of symmetry here, and we're talking about a line of symmetry here. Now there is no line of symmetry that passes kind of through this away, because one way to look at it is if this point were reflected about, then it would end up over here. But notice in our parallelogram that it does not end up over there. We could show that concept using our square, to where this vertex, when reflected about that line of symmetry, ends up being across that axis and creating that line of symmetry. So I'm going to erase a couple of these things, and we're down to our parallelogram, and there's our two lines of symmetry with our parallelogram. But with our orange square here, we have a line of symmetry here, we have a line of symmetry here, we have a line of symmetry here, and we have a line of symmetry there. And so we can count those lines of symmetry for our square. We can clear those drawings out. Here's another shape. We're trying to find lines of symmetry, so lines that would create a line of reflection like a mirror. There would be a line of symmetry, here would be a line of symmetry, but you can't place it anywhere else. You cannot place it here because, again, this point being reflected about would end up right over in there, and it doesn't quite work that way. And there's other ways to explain why that doesn't work, but that's one illustration. So I'll erase that drawing and those dotted lines. So we're sitting here with those two lines of symmetry. We could create other shapes. One thing I like to do when it deals with lines of symmetry is we actually have them build a shape, any shape that they want. When I say they, just our students. So here's a nice little shape that we could create. And what if our line of reflection, or our line of symmetry, is going to be right here? And bear with me for my not straight line. And we want to build the shape that is reflection about that red line. Therefore, I need to take a red trapezoid here, and I need to reflect it about that line. So I need to rotate it around and it's going to click in place right here. And then my yellow hexagon, here's where that reflection is going to be. And then my black oblong shape, we'll call it arrowhead, fits in right here. And so now we have established that line of symmetry, and we have now reflected the original drawing, which was on this side, about that line of symmetry and created the other shape. So that's one activity that you can do with students using pattern blocks to help build the concept of lines of symmetry and reflection. There are other ways to do it. You can build other shapes and create those lines of symmetry. They can count how many lines of symmetry that they have. They can describe in words how they know that it is a line of symmetry and how they know it's symmetrical and it has those reflective properties. And as you grow older, as students grow older, if you will, then you can do things like add the grid in there, and you can establish points on that grid that will that will allow students to see where this point thus reflects. This is an ordered pair, and so if my line of symmetry is this line, where is this going to reflect? And it will reflect to that point there. So as the students get older, you can use the square grids on this app and allow students to create ordered pairs, and where the points or the vertices on these shapes are going to be reflected on that coordinate grid. So that's just a quick rundown of it, but lines of symmetry is one way, or these pattern blocks can help teach the concepts behind lines of symmetry and lines of reflection. So thank you for watching. This is PiPad Mathematics, and I am Professor Lamb.